Welcome to JSR Maths Academy. Now let us observe a question. If alpha, comma, beta are the roots of x square plus bx plus q is equal to 0, and also of x to the power of 2n plus p to the power of n into x to the power of n plus q to the power of n is equal to 0, and if alpha by beta and beta by alpha are the roots of x to the power of n plus 1 plus x plus 1 whole to the power of n is equal to 0, then n must be an first option, an even integer second option, an odd integer third option, any integer fourth is none. As I mentioned that alpha and beta are roots of this quadratic equation, then sum of the roots is minus p, product of the roots alpha into beta is q, sum of the roots of alpha plus beta is minus p, and alpha into beta is q. As I mentioned, alpha and beta are the roots of this quadratic equation. X to the power of 2n plus p to the power of n into x to the power of n plus q to the power of n is equal to 0. In the place of x, if we substitute alpha, we get an equation 1, that is of alpha to the power of 2n plus p to the power of n into alpha to the power of n plus q to the power of n is equal to 0. Similarly, on substituting beta in the place of this x in this equation, we can get a second equation, that is of beta to the power of 2n plus p power n into beta power of n plus q power n is equal to 0. Now, on subtracting these two equations, we will get another equation, that is of alpha to the power of 2n minus beta to the power of 2n plus of, on taking p to the power of n as a common, this can be written as alpha to the power of n minus beta to the power of n. This is equal to 0. That means on subtracting this in these two equations, this term will be get cancelled. Then we get this equation. Now, on transporting this first term to other hand of equation, we get a p to the power of n into alpha power of n minus beta to the power of n is equal to minus of alpha to the power of 2n can be written as alpha to the power of n whole square minus beta power of n the whole square. Now, this RHS is in the form of a square minus b square. Then this can be written as p to the power of n is equal to minus of alpha to the power of n plus beta power of n into alpha to the power of n minus beta power of n. Here, this is a multiplier on and transporting this one to other hand of equation, it will get as an it becomes as a divisor. So this becomes a divisor here. Now these two terms will be cancelled. Then we get a p to the power of n is equal to minus of alpha to the power of n plus beta to the power of n. This is a third equation. Now, as I mentioned that alpha by beta and beta by alpha are the roots of this x to the power of n plus 1 plus x plus 1 to the power of n is equal to 0. Now, I am substituting the alpha by beta in the place of x. So, this we will get as an alpha by beta whole to the power of n plus 1 plus alpha by beta plus 1 whole to the power of n is equal to 0. Now, this power can be applicable for numerator and denominator individually, so that we can write it as an alpha to the power of n by beta power of n plus 1 plus alpha plus beta whole to the power of n by beta power of n is equal to 0. On taking LCM, we can write it as an alpha to the power of n plus beta power of n plus alpha plus beta whole to the power of n by beta power of n is equal to 0. And transporting beta power of n is equal to 0, to other hand of equation, this will be this becomes a 0. So we can write it as an alpha to the power of n plus beta power of n plus of alpha plus beta whole to the power of n is equal to 0. And we know that this value as a minus p to power of n, minus of p power n. Now, and we also know that alpha plus beta is minus p, and substituting this value, above equation can be written as minus of p power of n plus minus p whole to power of n is equal to 0. This equation, that is above equation, is true for the if and only if n is an even number. If n is an even number, then only sum of these two is equal to 0. That means n must be an even integer. That means our first option is our correct answer. Thank you friends for watching this video.